Okay, so we start out with this pretty lofty question of what am I like as a science teacher? And um, I just hope that I'm an educator that makes it clear that science is not just for those who have a knack for it. So often you hear that kids don't like science because it's hard, and I want my students to be able to know that it's an all-encompassing subject. It has potential to reach into any other field, and there's always going to be something a kid is good at in science, and that can engage them and hopefully engage them so much that they consider other aspects of science. So my goal is to make learning more approachable to all students by making the material more engaging, allowing for more hands-on experience, and having more collaborative brainstorming thinking happening in my classroom. I want kids to know that there's no wrong way of thinking, that um, their hypotheses, their conclusions, they are valid. And so we start with this mini unit plan. Really, the standards go back to their middle school standards. So these are the same subjects high school uses, but they're toned down for middle schoolers. So we look at mutations and how mutations have effects on our variation of traits. We have sexual versus asexual reproduction, and again, looking at variation in organisms and how those change um, between sexual and asexual reproduction. So, um, again, here the key term is variation. So we start day one looking at Punnett squares, and I asked the kids, how do you think it's come to be that these puppies they all have the same mom and dad, but they are different colors. So you see a black one, you see a sandy colored one. So I asked them to think about and brainstorm why they think there's so much variation among this litter, and who doesn't love puppies. So this will be like the opening to the unit, and we'll be focusing on sexual reproduction and variation. The goal here is to introduce Punnett squares in relation to recessive and dominant relationships. When parents come together to form offspring, their genes are combined, and there's variability among offspring. So they do a few virtual labs, just a few rounds of this Punnett square on the right here, and they see genotypes and how that affects offspring, and they'll see the relationships among these genotypes. And then we have a little activity, and it scientists at the bikini bottom, so that might be kind of fun for middle schoolers in particular. So we kind of close this lesson. We give them a clearer understanding of what's going on when we look at a genotype and we get a certain phenotype. And here they can kind of see and play with how a certain genotype would result in a different phenotype. So how come we can have two brown parents and still get a black puppy? So then we start talking about mutations, and there's a little bit of relation here. Some of these fun facts that I think will get them interested in it. And then we have a small lab where it's more hands-on and kids can see how mutations arrive in every generation and how it changes every generation. And so they see there's a little bit of math involved in here to further engage the kids. And I have some questions about that. And then we have this huge question of, well, okay, if sexual reproduction results in variation, what is asexual reproduction? And here I engage the students by using this little cartoon. You see on the wall we have a picture in it of the parent, and it says mom and dad. So I asked them, like, what does it mean when it says mom and dad? And kids will then come up with their own way of thinking and their own brainstorming. And it would make the material a little bit more engaging. It's kind of funny, I think, especially to a middle schooler. So even if we look at this cartoon we see there's a clear lack of genetic variation. So this connects back to the entire unit on sexual reproduction, and we look at different organisms here and how they reproduce. And then we go through and kind of do pros and cons of sexual and asexual reproduction. And then my goal is always to bring it back to the opening. We'll talk about why there was no variation in that cartoon between the snake and the parent organism. And then we'll bring it back to the puppies. Why was there variation there? And it all stems back to the mode of reproduction and the parents' genotypes.